a shape of a ship. And then when you look at the size of it, it is exactly 300 Royal Egyptian cubits. That's what Moses wrote in the book of Genesis. And so, either that's a coincidence or we're looking at the right object. And then we started doing scans. And these are non destructive geophysical scans that can peer below the soil, like radar and ERT. And they're showing a pattern of structure that you would not expect in nature.
High on the eastern horizon of Turkey, where the snow never leaves the shoulders of Mount Ararat, legends have long clung like mist to the stone. For centuries, this solitary peak has been more than a landmark. It has been a beacon of one of humanity's most enduring myths. Pilgrims, explorers, and dreamers have searched these ridges for generations, convinced that somewhere beneath the rock and ice lies a vessel of impossible scale, humanity's last refuge during the Great Flood. Most expeditions ended in disappointment, their findings dissolving into rumor or fierce controversy. Fleeting shadows on satellite photos promised much, but delivered little. To the scientific community, the Ark remained less an artifact than a powerful parable. Symbolic, but forever out of reach. And yet, the mountain refuses to let go of its secret. In 1959, Turkish cartographer İlhan Durupınar spotted a curious, boat-shaped formation on aerial photographs, an outline nearly the length described in the book of Genesis. This discovery ignited decades of debate. Was this a geological quirk, or the petrified skeleton of the Ark itself? For over half a century, the question remained locked. We simply didn't have the technology to strip away the mountain's camouflage. Human eyes were fooled by erosion, and basic tools couldn't see through tons of rock and soil. But now, the quest has gained a radical new partner. It's not the eyes of explorers, but the unblinking gaze of artificial intelligence. By feeding terabytes of data, from ground-penetrating radar, GPR, and high-resolution drone scans to ancient geological models, into advanced neural networks, AI has begun to comb through the Durupınar site. Where human judgment sees coincidence, algorithms detect patterns. Where imagination falters, data sharpens. For the first time, we are not just chasing shadows. AI has revealed subsurface structures, regular compartments, and even organic trace elements embedded deep within the rock. Details that align uncannily with ancient descriptions. The story that once belonged only to scripture and legend is being rewritten in the cold, hard language of science and code. But the deeper the search goes, the sharper the question becomes. Is this truly the Ark of Noah? Or have we stumbled upon something even more extraordinary? A message preserved in stone for reasons we have yet to understand. AI might have just done more than find a boat. It might have unlocked a planetary warning system. Long before the age of satellites and algorithms, humanity preserved its history in stories. Tales so powerful, they survived millennia, etched in clay and inked onto scrolls. Among them, few are as universal or as haunting as the tale of a flood that drowned the world. The book of Genesis tells of Noah, chosen to preserve life against the judgment of heaven, constructing a vessel of staggering size. But the Noah narrative is not a standalone event. This story echoes across the globe, suggesting a terrifying shared memory. Across Mesopotamia, the Epic of Gilgamesh, first recorded on clay tablets around 2100 BCE, describes Utnapishtim, warned of a divine deluge and instructed to build a massive boat to save his kin and animals. In ancient India, the Satapatha Brahmana recounts Manu, rescued by a giant fish who guided his ark through floodwaters. Even in China's early legends, Emperor Utom's a cataclysmic flood by carving channels through the earth, an echo of the same primal terror, fear for natural disaster. For decades, scholars dismissed them as mere metaphors, moral tales about human hubris. But modern science has since forced a reconsideration. In 1997, marine geologists William Ryan and Walter Pittman of Columbia University published groundbreaking research on the Black Sea flood hypothesis. By analyzing sediment cores, they argued that around 5600 BCE, rising Mediterranean waters breached the Bosporus, flooding the Black Sea basin with catastrophic force. Imagine a waterfall 200 times the volume of Niagara Falls, roaring for months, swallowing an inland freshwater lake and pushing ancient populations inland. This violent event, though debated in its precise dating, could have birthed the flood legends across the Near East. Further evidence came from archaeological surveys. In 2012, Robert Ballard, the legendary undersea explorer famous for finding the Titanic, conducted sonar mapping of the Black Sea floor. He uncovered evidence of ancient shorelines and settlements now submerged beneath hundreds of feet of water, villages swallowed by a flood of biblical proportions. "It's not just a story," Ballard remarked. "Something happened that left a permanent scar on human memory." This is the context for the peculiar anomaly on land, the Derupanar site. While many geologists attribute its boat-like shape to natural rock formations known as synclines, the persistence of the global flood myth, backed by scientific evidence of a catastrophic Black Sea inundation, forces us to look closer. When we weave together scripture, myth, and science, the flood ceases to look like isolated imagination. Instead, it resembles a fractured mosaic, preserving a sliver of an ancient catastrophe. But here's the catch. If these myths are true, and if the flood was real, why do we need AI to find the Ark? Because the mountain itself is a masterful deceiver, and the structure is now encased in rock, which means we need a tool that can pierce the geological armor and tell us if the symmetry, the dimensions, and the hidden compartments of the Derupanar Formation are merely geology, or the calculated design of humanity. And that tool is no longer the shovel. For centuries, the quest for the Ark was a test of endurance and faith. Explorers trekked through the rugged mountains, armed with maps, compasses, and an unshakable belief. But the mountain, covered in landslides and volcanic basalt, was a master of misdirection. You could stand directly on the Ark and still only see rock. In the 21st century, the hunt gained a new kind of partner, one that doesn't tire, doesn't blink, and can see patterns invisible to the human eye. Artificial intelligence. At its core, the AI used in archaeology is not some mystical oracle. It is, quite literally, mathematics at scale. Imagine we are feeding algorithms trained to recognize subtle relationships across oceans of data. In the context of Mount Ararat, this means synthesizing vast, seemingly disparate datasets into a single, cohesive image. High-resolution drone photography, thermal infrared scans that penetrate vegetation, and, most importantly, ground-penetrating radar, GPR. Think of GPR as a type of sonic X-ray. It sends electromagnetic pulses into the ground and measures the echoes that bounce back. When a pulse hits something dense, say solid rock, it returns one signal. When it hits an unnatural void, a chamber, or a material with different density, like wood or sediment inside a structure, it returns a very different signal. The GPR creates thousands of these signals, generating a complex, three-dimensional subterranean map. Now, here's where AI becomes the game changer. For a human researcher, distinguishing between the GPR signal of a natural basalt dike, volcanic rock, and the signal of an ancient wooden bulkhead is incredibly difficult. The data is too noisy. But researchers feed these GPR terabytes into a machine learning classifier. This algorithm is trained on thousands of known geological and man-made structures. It learns to recognize the signature of human design, regular spacing, perfect right angles, and repeating rectilinear patterns, which are anomalies in natural geology. The results are already rewriting history globally. In 2018, archaeologists at the University of Arkansas deployed machine learning algorithms on LIDAR data in Belize, revealing over 60,000 hidden Maya structures beneath dense jungle canopy that human surveyors missed. Canuto et al. Science, 2018. At the Durupanar site, AI's classification was applied to GPR scans conducted by a joint team from Istanbul Technical University and American researchers, 2019-2023. Their algorithms identified subsurface cavities that appeared unnaturally regular. Multiple rectangular voids inconsistent with typical geological activity. The data suggested a structure 150 meters long, with internal support structures and repeating internal alignments exactly where one might expect to find bulkheads or compartment walls inside a massive vessel. The AI, in essence, gave us an image of a giant, compartmentalized object buried deep beneath the Earth's surface. It cannot confirm the identity of Noah's Ark, but it can confirm the presence of a highly improbable man-made-like structure where one shouldn't exist. This is where the story grows tantalizing. For decades, the Ark was treated as a relic of faith. Now, AI has entered the stage, not to prove a miracle, but to ask a different question. If the pattern-finding machine is seeing the faint fingerprints of human design, what terrifying purpose did this colossal structure serve, and what is truly embedded within its rock-hard chambers? The answer lies in the strange, organic anomalies detected inside. From a distance, the Durupanar Formation is nothing more than a peculiar scar on the side of a Turkish ridge. But when the AI's GPR data is layered over the topography, the scar transforms into a blueprint of impossibility. The core of the controversy lies in the site's dimensions and subsurface content. Measuring approximately 150 meters long, the formation aligns almost exactly with the 300 cubits length cited in the biblical book of Genesis for Noah's Ark. This geometric correspondence, a perfect 1.1 match in scale with a legendary vessel, is what first drew the eye of explorer Ron Wyatt, and later, the cold scrutiny of the algorithms. Coincidence is possible, but highly improbable when mathematical precision is at play. The most compelling evidence comes not from the surface shape, but from the depths. Following the AI's identification of non-random, rectilinear anomalies, as detailed in Section 2, researchers focused intensive GPR surveys on those specific coordinates. The results, published by the Ara Ibrahim Chechen University team 2023, revealed multiple, regularly spaced reflections inconsistent with natural stratification. They detected voids and solid structures running parallel to the formation's long axis, spaced at remarkably consistent intervals, suggesting internal bulkheads or ribbing. Think about it. Nature builds curves. Erosion creates randomness. But AI highlights an underlying structure that screams design. Furthermore, the chemical analysis of the rock and soil samples taken from within the formation adds another layer of intrigue. While mainstream geologists like Lawrence Collins, 2006, argued that the site is merely hardened mud flow, Other researchers have consistently reported the detection of unusual chemical concentrations. Soil cores taken in the 1990s and later analyzed by Turkish-American teams reportedly showed high levels of manganese, iron, and trace organic carbon. These elements, particularly when found together in localized concentrations, can be the chemical signature of ancient, fossilized timber that has been replaced by minerals over millennia. It's the ghost of wood, locked within stone. In 2020, the ARI team claimed to have found what they termed laminated materials, layered formations that some proponents argue represent the petrified layers of the hull's deck or decking. While skeptics insist these are natural basalt dikes, volcanic injections, the AI's role is to point out the crucial, statistically impossible fact. Why do these natural chemical signatures and rectilinear structures appear only within the 150-meter-long, perfectly boat-shaped anomaly? The data refuses to be dismissed by simple geological explanations. The spatial correlation between the ship's dimensions, the internal rectangular GPR voids, and the organic trace elements is what elevates the Durupinar site beyond a mere curiosity. It suggests that a massive engineered object, likely composed of timber and held together by metal elements, explaining the high iron content, was encased by a geological event, preserving its structural integrity while fossilizing its material. The mountain, aided by time, has turned the ultimate vessel of survival into its ultimate disguise. But AI has pierced that veil. If this truly is an engineered structure, then the Ark is not just a relic of the past. It is a profound message of precaution and advanced knowledge from a forgotten time. What other messages are encoded in its geometry, waiting for the AI to decode? The data presented by AI and GPR is compelling. A massive, symmetrical, rectilinear structure, replete with organic traces, buried at the precise length of the mythical Ark. But in the world of archaeology, compelling evidence is often met with fierce skepticism. This is where the debate truly sharpens, dividing the community between those who see a natural formation and those who see a monument to survival. For mainstream geologists, the anomalies highlighted by AI are simply a matter of pattern recognition error. Humans, and the AI algorithms trained by them, are wired to find order in chaos. Dr. Lawrence Collins, 2006, and others have argued convincingly that the internal rib-like structures detected by GPR are merely the result of natural rock folding and hardened mud flow, lavas and mud flows common in a volcanic region like Ari province. Similarly, the high iron content could be attributed to local geological mineralization, not ancient metal fasteners. The mountain, they conclude, is simply a geological curiosity that happens to resemble a boat. Yet, this skeptical view fails to fully account for the mathematical precision uncovered by the latest elevation mapping. Satellite-based analysis conducted by groups like the Istanbul Technical University, 2018, showed that the Durupinar outline is not just long, but strikingly symmetrical. The bow tapers at a consistent, engineered-like ratio. The sides run nearly parallel, and the stern flares with a geometric neatness rarely seen in natural formations. As one researcher noted, nature rarely draws straight lines. When it does, and they align perfectly with ancient text, we must pay attention to the statistical odds. But the Ark's story doesn't end with one mound. If the flood was a universal trauma, as AI deduced from global myth correlation in the previous analysis, then there should be other scars on the landscape, and Turkey is filled with them. Consider the Ararat anomaly, a dark shadow captured in aerial photographs taken by the U.S. Air Force in 1949, and later scrutinized by authors like Porcher Taylor. This anomaly, situated high on Mount Ararat's ice cap, suggests another possible buried structure. While shrouded in secrecy and inaccessible to GPR, its very existence reinforces the idea that something is concealed beneath the region's frozen geology. Moving further southwest, the vast subterranean labyrinth of Derinkuyu Underground City tells a different but equally compelling survival story. Discovered in the 1960s, this complex could shelter up to 20,000 people, complete with ventilation shafts and storage rooms. Studied extensively by Turkish archaeologist Mehmet Özdoğan, 1999. Its purpose was clearly defense against cataclysmic threats, whether invasion, climate change, or perhaps even the lingering, terrifying memory of great floods. Derinkuyu becomes, in this sense, a stone-carved echo of humanity's obsession with preparedness. Finally, there is Lake Van, where a team led by Mustafa Akush, 2017, reported the discovery of massive, 4-kilometer-long stone walls submerged beneath the waters. The ruins hint at a lost fortress or settlement drowned by the rising lake. None of these sites, the anomaly, Derinkuyu, or Lake Van, provide irrefutable proof of Noah's Ark. Yet, AI's primary function is to detect non-random correlation. When the mathematical symmetry of Durupinar is placed alongside the consistent flood myths and the regional evidence of massive sudden concealment, a new hypothesis emerges. The Ark is less about a single ship and more about an encoded pattern. It represents not just a vessel, but a geometry of survival, a blueprint for saving civilization from the waters of destruction. If AI can now read this code hidden beneath the mountain, what terrifying future possibility does the Ark's geometry warn us about? If the Durupinar Formation is an engineered structure, a conclusion powerfully supported by the AI's detection of non-random geometry and rectilinear compartments, then the story we're reading is not just about a single flood. It's about a pattern. It forces us to ask, what did the builders know about the planet that we have forgotten? The narrative emerging from the AI-validated data is one of cyclical catastrophe. Climate scientists have long warned that Earth's climate system is capable of abrupt, devastating shifts. Models and proxy records show that stable systems can quickly flip. In 2001, Ganopolsky and Rahmstorf used climate models to demonstrate how relatively small changes can trigger rapid transitions in climate states, provoking dramatic regional or even global shifts. This volatility provides the perfect context for the flood myths. The massive climate swings at the end of the last ice age, including the debated Younger Dryas period, showed communities confronting sudden, large-scale disruptions. The Ark, in this light, becomes less an isolated miracle and more a calculated, necessary technological response to a planetary rhythm of destruction. AI, by correlating the mathematical design of the Durupinar site with these records of abrupt climate change and global flood myths, as discussed in Section 4, suggests that Noah's Ark was not simply a boat to save a family. It was a deliberate survival technology. This leads to the most radical hypothesis. The Ark was designed to be a time capsule, a massive, deliberately engineered structure meant to fossilize quickly and withstand millennia, carrying an encoded message for the future. Why would they choose this method? because they knew that the next human civilization, us, would eventually gain the tools, the GPR to see through rock, and the AI to decode the patterns, to access the warning. The structure on Mount Ararat is, therefore, a symbol for intentional memory preservation. It's the ultimate blueprint for saving human knowledge, seed stock, and potentially DNA, designed to be stored in the region most likely to survive the next inevitable shift. Some commentators have taken this hypothesis a step further, proposing that the Ark and other contemporaneous structures, like the precise astronomical alignment of Göbekli Tepe, reflect a knowledge base out of time. This implies a lost, advanced prehistoric technical tradition, a civilization that perished in the cataclysm but left behind their survival handbook. The builders weren't just fleeing the water, they were planning the restart. The urgent lesson, powerfully emboldened by AI's pattern finding, is not a demand to prove one boat or another. It is a terrifying warning. Earth's systems can flip. Humans have faced abrupt crises before, and our ancestors encoded those experiences into stories and into this monumental buried technology. The Ark is less about history than it is about prophecy. If the past repeats in patterns, then the buried lessons around Ararat are not curiosities to be dismissed. They are warnings in stone and sediment, messages that AI has finally translated. The question is, with the AI telling us that the design is intentional and the message is real, what terrifying action must we take now before the water rises again? The mountains of eastern Turkey have always been places of mystery. They rise like jagged guardians, hiding their secrets in snowfields and shifting rock, while at their feet, villages tell stories that echo across thousands of years. Somewhere among these slopes, the idea of a vessel large enough to carry the seed of all life has haunted the human imagination. Now, the combination of archaeology and artificial intelligence has pulled us out of the realm of pure myth. What the algorithms reveal is not a single clear photograph of a wooden hull preserved against time. Instead, they highlight patterns, non-random geometry, rectilinear subsurface anomalies, chemical signatures of fossilized materials, and the terrifying echo of a flood myth across all ancient cultures. AI tells us that the formation is statistically improbable to be natural geology. The Ark, in this light, becomes more than a boat. It is a lens through which humanity has always tried to understand catastrophe, resilience, and rebirth. It represents a single, monumental structure built by a people who experienced the worst the planet could offer and who decided that the only way to save the future was to bury the past. There is a sobering weight to this discovery. Climate models show that the world can shift suddenly. History shows that civilizations often ignore the warning signs until it is too late. If Noah's Ark is more than metaphor, if it is memory and geometry, then it reminds us that preparedness is not folly, but an existential necessity. In the end, the most compelling question may not be where the Ark rests, or whether the timbers of a prehistoric vessel still lie beneath Ararat stone. It is the question of purpose. Who was the Ark really built for? Was it just the record of one community, one people preserving their lifeline, hoping to restart their existence? Or was it a message carved for the distant future, for us, the civilization that would eventually invent the machine capable of breaking the ancient lock, the artificial intelligence? The flood, after all, may not be a story of the past. It may be a cycle still turning, and the Ark may be less about survival then than survival now.